Any questions? Okay. I don't see any questions. If you do come up with a question, you can ask me later on during the break or when you're in your breakout groups or at the end of class as well. So let's begin our discussion today with the other senses. So last week we saw one important sense, an important special sense, right? The sense of vision, which is through the eye. But here you can see on this figure an indication or a hint of what we will cover today. We will cover some of the other special senses, like the ear, right? The ear, which is involved in hearing and balance. Hearing and balance. So let's take a look at this next organ, right? The ear. Let me look at the PowerPoints here. And the PowerPoints you'll find there, it says lab 4 within your documents. Lab 4, the ear and the other senses. Okay, so where you have the folder there that has the PowerPoints for the first practical, right? You will find there PowerPoints for the ear and so forth. So now let's take a look at these PowerPoints, and I'm going to use chapter 15 from the textbook. Now, if you have the lab manual, those of you who have the actual lab manual, I invite you to open up to Unit 15 in your lab manuals. Open up to Unit 15. If you have the ebook lab manual, right, for online, make a note of it, right? So write that down in a piece of paper or in your notebook, Unit 15. Okay, so look in Unit 15, beginning on page 403. 403. Now, it might vary. If you have a different edition, Ammerman Lab Manual, you might have the latest edition. I think the latest one already just came out, the 4th edition. Or if you have a past one, look in Unit 15 where it has the anatomy of the ear. Okay, the anatomy of the ear. Okay, any questions? The student with their microphone, if you could please. Okay, thank you. All right, so there on page 403, you can see, page 403, you see a figure of the ear. So I'm going to turn to the page here in this chapter of your textbook. Now I'm using the textbook, and I'll be using the Ammerman textbook. The OpenStax doesn't have the greatest pictures in the world, so I prefer to use the Ammerman textbook. In fact, the Ammerman textbook is the official book. So I'll use this book, and it has a similar figure like you have there in your lab manual. So those of you using a lab manual, you see a figure similar to this. The only difference is that one of the parts here is colored in blue. Other than that, it's practically the same. So here in the textbook, though, I'll use figure 15.24 so that we can discuss the ear. Okay, so let's look at the ear. Now the ear has two functions. Okay, it has an important function there, which is a special sense known as hearing, right? Hearing, right? The ability to hear. So you can all hear that, right? I was clapping my hands. But also another sense. What is the other? Well, I don't know if it's considered a sense, but it is an ability. What is the other ability that the ear provides? Okay, balancing, very good. Balance, also which is referred to as equilibrium, right? Equilibrium or balance. Okay? So we're going to talk about the parts of the ear. And in lecture class, we'll discuss more specifically and in more detail how hearing is produced, how balance is carried out, and so forth. Here in lab class, though, we want to spend more time with the anatomy. I may mention a few brief things about the functions or physiology, but very brief, because your first exam, your first lab exam is a practical, right? So we'll be mainly naming structures and things. So let's take a look at the ear, and here you can see the ear is divided into 3 areas or 3 sections, right? Okay, so let me get a pointer here, and I'm going to use a fun color, right? My fun pointer there, and here you can see that I'm pointing at some of the parts here of the, okay, some of the parts of the outer ear. Okay, so let's begin our discussion with the outer ear. Okay, so the outer, by the way, the outer ear is also referred to as the external ear. The external ear. But look at the brackets. If you look at the brackets carefully, the external ear does consist of a couple of important things. A few important things. So let's look at the important things that are found in the outer or external ear. One important thing that we find in the outer ear section is this thing that you have on the side of your heads. Okay, see that thing on the side of your heads? Everybody right now, take one of your hands and touch that thing that you have on the side of your head. It feels kind of rounded or oval shaped, right? There are sometimes people who have a pointy one. Pointy. What we call that structure there that you have on the side of your head is called the auricle or the pinna. Auricle or pinna. You may have heard the word auricles before. Where do you remember that you've seen the word auricle in the past? In what organ? In the heart. Remember the heart? On the outer surface it had auricles? Okay, very good. So what does auricle mean? Auricle means ear, right? That's why those things that you had on the outer surface of your heart were called auricles, because they look like ears. They look like ears of some animal, like a teddy bear or a dog. Anyway, here on the humans, the auricle is that rounded structure that looks kind of like a ring there, right? Also called the pinna. Either answer is acceptable, auricle or pinna. Now, the auricle or pinna is made mostly of elastic cartilage. So right now, take your hand and pull on your auricle gently. Don't pull too much. Pull gently. Or fold it slightly anteriorly. And then let go. It recoils back very easily, right? That's because it mostly is elastic cartilage. Of course, there is skin covering the ear, and some people have some small little bit of fuzz hair on their ears. But regardless of that, most of the tissue within the auricle is made of elastic cartilage, and that's why when a child is misbehaving, you can pull on their ear and not worry that it will stay deformed, right? It usually will recoil back into shape. By the way, never pull on a child's ear too strong that you rip the skin or you hurt them, right? Anyway, that is called the auricle or pinna. So that's one important part here of the outer ear. Let's take a look at another important part here, or structure in the outer ear. The next structure that we see here in the outer ear is this canal. Okay, ooh, that canal that everyone likes to scratch, right? Okay, scratch and put their fingers in when it's itchy. Sometimes there's water in there. However, that canal that you see there is called the external auditory canal, also known as the external auditory meatus. Some books even call it the external acoustic meatus. So let me put some of the other few names that you might find with this canal. Acoustic meatus, auditory canal, okay? Either way, when you name this thing that you see right there, that canal that you see that goes from your outer end of your auricle and goes inward, make sure that you name it as, let me fix the size here so that it can fit in. I guess I can make it just a little bit larger. Okay, make sure that you name it either as a canal or a meatus. Canal or meatus, okay? Auditory canal or acoustic meatus. Okay, why not something else like a duct or a tube? The reason is because we do have a few other things that are called ducts or tubes. In a moment, we'll see something that's called sometimes the auditory tube. Okay? All right, so anyway, we can take a look at this figure that we have there, the external auditory canal. Now, in the external auditory canal, we have these tiny little glands. You don't see it on the figure, so you probably don't have to worry about naming those here in lab class. But we will talk about the tiny glands that we have here in the external auditory canal. Tiny glands that produce what? Does anybody know? Tiny glands that produce what?
Earwax.
Earwax, very good, which is also more scientifically known as cerumen. Cerumen. We'll discuss that in lecture class. Okay? By the way, the cerumen is good. You might seem that it looks nasty, right? When you clean your ears, it looks nasty and it doesn't look good. Maybe it doesn't even smell good, whatever. But the earwax is actually a good substance. It protects your external auditory canal. It protects from water building up in your ears. It protects from insects coming into your ears. It protects from fungus and bacteria growing in your external auditory canal. That wax is important. So now you can see that it's important that you have wax and that you leave it alone. Now, I know that some of you on a daily basis will clean out your ears with Q-tips. The Q-tip company says on the box itself of the Q-tips, it says itself that it should not be used for cleaning out your ears. Okay, meaning that you should actually not put anything into your external auditory canal. Okay, it should be left alone. Now, I know some of you may build up too much earwax, but it doesn't happen often. It happens maybe after a few months. Okay, so if you're going to clean out your ears, right, you shouldn't do it every day. I know it feels itchy, but you know why it's itchy? It feels itchy because it's dry. It's itchy because you're constantly cleaning it out. I'm telling you this, I'm just sharing this with you. You don't have to follow what I say, but the earwax should just be left alone. I know a lot of you might clean it out every day, but you should actually leave it alone. They do say an honest ENT specialist, right, an ear specialist will tell you you shouldn't put anything in your ears. No Q-tips, no paper clips, no pencils, no toothpicks, whatever. I mean, people put all kind of things in there to scratch it. Those are dangerous things, okay? But leave it alone. If you're going to clean your ear, you should clean probably as far as your pinky can reach, which would mean as far as this area at the most, okay? Your pinky most likely doesn't fit any further than that. So you might clean up as this far. Now, how can you clean out when you have too much wax after several weeks? What they do is that they sell these syringes in pharmacies, right? Little syringe, like a little rubber ball with a tube at the end. You put warm water in it, right? And you tilt your head to one side and you clean the ear that seems to have too much wax or clogged. You clean it out gently with warm water, not hot, but just warm, and let it flush out the excess wax. Okay, that should be fine enough. Now, if you have trouble, you can always tell your doctor to do it for you. Okay, but yes, I'm recommending something for your own benefit, guys, because if you clean out the wax every day, you're going to start suffering from dry ears. You can suffer from more water buildup there, and with water buildup, you're going to have fungal growth, bacterial growth, insects coming in, and all sorts of other problems, and then have constant ear infections, constant external ear infections, which then is going to have to be treated with antibiotics. Yes, irrigation is the best way to clean it out. Okay? And irrigation should be done only once in a while. It shouldn't be done like every day. It should be done like every few weeks if you feel that you have excess wax. Other than that, with a little moist rag, a clean, very clean, moist rag, don't put alcohol or anything like that, but a clean, moist rag, you can clean out your external ear, all of this, right? And then you can come as far as where your pinky reaches, right? Your pinky most likely reaches as far as where I'm pointing at with the finger. I doubt your pinky can reach all the way in. If it does, be careful. You shouldn't go farther than that, okay? Because you might scrape and scratch the lining here of your external ear, and also you could even puncture the tympanic membrane. Okay, so just a few recommendations, guys. Ask your ear specialist if you're not sure, okay? Okay. Any questions so far of the external auditory canal? We'll talk about that cerumen in more detail in lecture. Okay, now the canal here serves a purpose. Its purpose is to transport the sound waves, right? Sound waves come in, and they come in this way, where they hit this membrane that you see at the end of the external auditory canal. At the end of the external auditory canal, you have a structure there that looks like a drum. Some people call it the eardrum. Okay, that's called the tympanic membrane. Okay, so that's the correct word for this membrane. Let me underline that, tympanic, and make the underline just a little bit smaller there, and membrane. Okay, tympanic membrane. The word tympanic means that it vibrates, right? That it's like a musical instrument that people play, right? Those drums. Anyway, it vibrates with the sound waves coming into your ear. And as it vibrates, it will cause some other structures to shake and move and vibrate as well, which we'll get to in a moment. Okay, but the tympanic membrane, is that part of the outer ear, or is it part of the middle ear, which is the next section we'll talk about? Some books refer to it as being part of the outer ear. Other books refer to the tympanic membrane as being part of a barrier that divides the outer ear from the middle ear. Okay, so really I'm not going to really worry too much about where it's located, you know, if it's in the outer ear or middle ear, but I'll just say it's a barrier there, like a drum, right in between and separating the outer ear from the middle ear. Okay, so not to make things complicated, we'll just say there that it is part of a barrier there, or a sort of like a wall there in between the, in between the outer and middle ear. So that means now we can move on to this next portion here, the middle ear. Okay, any questions so far? Okay, by the way, I think Professor Ammerman labels the tympanic membrane as part of the outer ear. But just to make it more simpler, we'll just say kind of like a barrier. It's in fact a good marker there, a good marker that helps us understand where the outer ear ends and where the middle ear begins. So now let's look at the middle ear. So one thing that we have here in the middle ear, right, is we have here a space, right? A space sometimes referred to as the tympanic cavity. The middle ear sometimes is called the tympanic cavity. Tympanic cavity. It is, as you can see, kind of like a cavity. Let's look at it. You see right there? It's a small little space or cavity, but with important things. So what important things do we have in the tympanic cavity or middle ear? One important thing that we have here in the tympanic cavity or middle ear is these tiny little bones, right? Tiny bones in our middle ear. Okay, let me point out the name of the bones. They're called the auditory ossicles, or simply just the ossicles. Okay, let me underline the name of these ossicles now. There are 3 ossicles, as you can see. So let's look at them in order. First, we have one that looks like a hammer or a club. The one that you see there that looks like a hammer or a club, that one is called the malleus. The malleus. So you see right there one that looks like a hammer or a club, that's called the malleus. Let me see if I have another figure to somewhat look at the shape or the general structure of the malleus. We'll come back to this figure in a moment. But right here you can see with this figure, I'm going to use this figure a lot more in lecture class, but I wanted to show you here some of the parts here of the ear. And you see right there that one that looks like a knob, like a door handle, right? Like a doorknob. Anyway, you see that thing? Looks kind of like it has a stem and a bump at the end. That is called the malleus. Are they bones? Yes, these are tiny little bones within your middle ear. Tiny little bones. So in 203 you studied 200 bones, but your instructor probably told you there are actually 206 bones. But you learned about 200 different bones, right? These are the other 6 bones, the ones that you have in your ears, right? They're called the ossicles. So the one I'm pointing here is the malleus, which kind of looks like a club. Okay, let's see if I have any other pictures there. If I do find any, I'll show you. And with models, I'll show you some pictures as well of the malleus with models and other photographs. Anyway, let's go back to my diagram. So that's one, the malleus. Next we have, by the way, the malleus, if you look carefully at the malleus right here. Let me move my arrow. Okay, I'm just moving my arrow a little. Okay, you see my malleus? I'm pointing kind of like at the stem of the malleus. And you see that the malleus is attached to the internal surface, the inner surface of the tympanic membrane. See, the malleus is attached to the inner surface of the tympanic membrane. So you see, when the tympanic membrane vibrates with sound waves, it causes the malleus to shake and vibrate as well, because it's attached to the inner surface. Okay, so that's something I wanted to share with you. Okay, next. The next ossicle is the one that follows. It articulates with the malleus, And that's one that you see right here that I'm pointing at. Some books describe it like the shape of what blacksmiths use. A blacksmith's a person who works with hot metal. They pound hot metal. And it's a thing, a big heavy thing called an anvil. So I don't know if it actually looks like an anvil. It doesn't look so much like an anvil to me, but some books the books refer to as the incus. The incus is something that looks like an anvil. I think these are words that come from the Greek language. Anyway, let me see if I can show you another figure of the incus. And right here, if I move my arrow, right there, you can see that the malleus articulates with that bone that you see I'm pointing at called the incus. Okay? It kind of looks like a hook, right? It kind of looks like a wrench. You know, it has the top part there like a wrench, and then it has a little tail that curves downward. Right here, you can see the tail of the incus. Okay? Anyway, going back to my first figure, right here you can see the incus, and you can see that little sort of like stem or curved tail of the incus. Okay? Does that serve a purpose? Yes. The incus serves the purpose so that it can articulate with the next ossicle. And your next ossicle is the one that you see there that looks very, very typical shape. Looks like what you use when you ride a horse. Those of you who have ever been horseback riding, has anybody ever gone horseback riding or likes to go horseback riding? Maybe somebody grew up on a farm. No, I've done it before. It's fun. But if you ever ridden a horse, they have this thing that you put your foot in, right? You put your foot in. It's called stirrups. So the name of that thing looks like stirrups, right? The stirrups that you put your foot in when you ride a horse. It's called the stapes. So that incus articulates with the stapes, right? Articulates with the stapes more deeper inside, right? So there you can see the stapes. Let's see if I have another figure for stapes. And right here, you see that thing? Kind of looks curved, bell-shaped, okay? That is the stapes, okay? Now, the stapes has that typical shape, kind of curved, okay? Kind of like stirrups that people use when they ride a horse, okay? And one important thing that the stapes does, so let's go back to my previous picture, figure 1524 again, from chapter 15 in the textbook. If you're following me, by the way, with your lab manual, it's on the same page, page 403. All these things are on the same page, page 403. Now, anyway, you see that stapes there? It articulates with the incus, but the base of the stapes, you see right here, looks kind of oval shaped. Let me point at the base. See, I'm pointing at the base of the stapes, the bottom or the internal structure there of that stapes. The base looks oval shaped, kind of like a pill or, oval. That base covers a window that we have right there. The window that it covers is called, I'm pointing at the window, but the window's covered right there, like a hole. It's called the oval window. So the base of the stapes covers the oval window that we have there, the oval window, which is a window on your internal ear, the internal ear. We'll get to the internal ear in another couple of minutes. But yes, let me see if I have another figure to show you the base of the stapes. And once again, here you can see the stapes, and look at the base of the stapes covers an oval window there that we have in our internal ear. The oval window, by the way, is generally always covered there by the stapes, covered by that base of the stapes, right? So when the stapes moves, right, it shakes, vibrates, it plunges like a plunger. I'm sure everybody or almost everyone has a plunger in their bathrooms, right? A plunger, you have a plunger at home in your bathroom. So that stapes plunges like back and forth into the oval window. The oval window, by the way, is a hole there covered by the stapes, and the oval window is part here of your inner ear, your internal or inner ear. That we're going to discuss in another minute or so. Okay, but anyway, just wanted to show this representation there. This, by the way, is a schematic representation. Schematic. What you see up here, that thing looks like a snail, is actually always coiled like that. Just to represent it, they use the schematic representation where they uncoil it. In reality, it doesn't uncoil like that. It does not do that. But just to show you here how these fluids flow and where they go. You see some waves there. Those are fluids that are flowing within your inner ear. We'll discuss a lot of that in lecture. Now, anyway, going back to the stapes there, the stapes covers that oval window that I'm pointing at. So when you look at some models or pictures, you might see the oval window, right, that has that sort of oval shape. You can see an example above there. Right there you see the oval window. And close to it, there's a smaller window that's rounded. We call it the round window. Let's see if I have another figure. Let's see if I can find another figure that shows the oval window and also the round window. So we have there a couple of windows there, a couple of windows within our inner ear. One window is the one that I'm pointing at. That's called the oval window. Once again, covered by the bone that you see right there. This bone is called the stapes. Okay, the stapes. Okay, and the other smaller window is actually rounded shape. See, rounder. Okay, that's called the round window. So both of those windows are windows there that we have in our inner ear. Now, before we move on to the inner ear, I want to go back to my ear diagram once again. So there we can see the oval window, and there's also a representation here of the round window. Now anyway, the round window, by the way, is not covered by any bone. It's not covered by a bone, but there's a very thin membrane there, a thin membrane that covers it. A thin membrane that kind of covers it. Okay, anyway, one other important thing here within the middle ear. So that covers our ossicles. But one other important thing that we have here in the middle ear is there at the bottom of the middle ear, right about here, at the floor of the middle ear, you see at the floor? At the floor or at the bottom of the middle ear, we have a hole there, an opening that leads into a tube. You see that duct or tube? It comes down this way, and that's an important tube that we have there. Let me point at the tube. Okay, if you look at the figure there, the tube is called the pharyngotympanic tube. Pharyngotympanic tube. It's called this way because of what it does, right? The pharyngotympanic tube, this is the tube, by the way. Make sure that you name this tube, right? Not anything else like a canal or channel, but it's called a tube to be specific. Okay? That communicates, right? Very good, Melissa. Communicates your middle ear, which is once again sometimes called the tympanic cavity, communicates your middle ear to your pharynx, to your throat. Okay, so what purpose would it serve? It communicates your middle ear to your pharynx, and therefore it's a great way to help release, helps to release the pressure sometimes that builds up in your middle ear. Okay, pressure that can build up in your middle ear. Sometimes pressure builds up in your middle ear when you go different altitudes. If you go up into, high, up in on a plane, or you go up into the mountains, or sometimes if you go below sea level, like on a subway train, you go below the street level. Sometimes it goes under the rivers to get from Queens to Manhattan or Brooklyn to Manhattan. And you feel the pressure build up in your middle ear. So that tube or pharyngotympanic tube is important to release the pressure that can build up in your middle ear. The pressure which can sometimes cause discomfort or even pain. Okay?
Professor, does it also drain fluid?
Does it drain fluid? No. Normally it doesn't. Normally it doesn't. However, it could drain fluid, Kathleen, if you had an infection in your middle ear. If you had an infection in the middle ear, right, sometimes that pus, that secretion, that fluid that builds up in your middle ear can be drained out, and you'll feel a, you know, a taste, not a good taste, right? It doesn't taste so well. You might feel it in your throat. See, I feel something funny in my throat, and I have pain in my middle ear. Okay, that might indicate you might have a middle ear infection. Okay, also, this tube is an explanation. The tube does, by the way, explain why sometimes when you have a throat infection, I'm sure many of you have had throat infections in the last few years, right? If you've had a throat infection, sometimes it spreads up into your middle ear, right? So that's why you can see why does a doctor look into your ear when you have a throat infection, when your throat hurts?
They want to see if it's inflamed.
Exactly. They want to see if your middle ear has been also affected, right? Because it can spread. An infection from your throat can spread to your middle ear. And that's very common, by the way. When you have a pharyngitis, right? When you have pharyngitis, it often will spread to your middle ear. Now, no big deal. You can treat it with antibiotics, and you should be okay. But yeah, sometimes when you have a throat infection, you start to feel pain in your ears as well. You say, my ears hurt. My throat is inflamed. I have an infection in my throat. I can see from the mirror. But why do my ears hurt? And that's because of this communication here. Now, one other important thing about this communication here is that the pharyngotympanic tube is called by a couple of other ways as well. Anybody know the other ways that we call this tube? Anybody know what is the other names?
Tube?
Yeah, sometimes it's called eustachian tube or auditory tube. Yes, or auditory tube. Okay, so I'll put those names down as well. Eustachian tube is a very common name. That's probably the most common name that I've seen for this tube, the eustachian tube. Auditory tube, I don't like to use that word because auditory tube can be confused with auditory canal. The auditory canal is the one that we saw earlier. So don't confuse the word canal with the tube here. Regardless of it, whatever you name it, make sure that you name it as a tube, right? Whether it's pharyngotympanic tube, eustachian tube, or some other tube. Okay, so the importance of this tube is to equalize the pressure in your middle ear. To equalize the pressure. Okay, baby, sometimes pressure builds up in the middle ear. And sometimes a baby on an airplane is crying and crying and crying. You have no idea why they keep crying so much. Maybe give them a pacifier. Maybe give them their bottle of milk, right? And sometimes moving your jaw, moving your throat muscles. Right now you can even try it. Open your jaw, make a few movements. Do you feel the pressure in your middle ear somewhat being released? Probably not much, because we're at sea level. But sometimes when the pressure builds up, just moving your jaw, opening your mouth a little, chewing on something might help. Okay? I'm sure all of you have experienced that build-up pressure in your middle ear. Yes, especially on a plane or even on a subway. Next time you go on the subway, you go between the boroughs. Because the trains go between boroughs, they go under rivers, right? They go under the East River. They go in between Queens and Brooklyn under a different river, and so forth. So when you go on a train, especially when it goes under a river from Manhattan to Queens or Queens to Manhattan, Brooklyn to Manhattan, and so forth, you feel that pressure, right? So now you know what to do to release that pressure. Okay, any questions about the middle ear? Any questions? Okay, a lot of interesting things here with the ear. But let's move on, though, to now the final portion here of the ear. And the final portion of the ear is the one that you see here called the inner or internal ear. Okay, let me point at the word internal or inner ear. Okay, so let's look at the inner ear now. Now, if you look at the inner ear, if you look carefully, you see that there is various structures, but besides that, there is layers as well. Okay, so I'm going to use my camera for a moment to demonstrate the two layers, right, that make up the inner ear. Now you can see that we have bones, right? There's bones surrounding your inner ear. We have the bony structures there of the temporal bone. We have bony structures perhaps even of the sphenoid bone. Most of it is temporal bone though. You can see a lot of temporal bone here. You don't have to worry about learning the bones that surround the inner ear. But you can see they are part of spongy material, right? Spongy bone of the temporal bone. Anyway, what we want to focus on, though, is the inner ear. Okay, so let's look at the inner ear. Now, you see that the inner ear has some interesting parts. A part that looks like a snail, right here. Okay, a part that looks like bubbles, right here. Right, and then you have a part here that looks like onion rings. How many of you like to eat onion rings when you go to this, whatever, a fast food place, whether it's Burger King or McDonald's, whatever? I like onion rings. Anyway, you see some rings there. Okay, so there's different parts here. However, if we look closely, if we dissect the inner ear, if we dissect any part of the inner ear, we will find that there are also two parts, two layers, sort of like two layers, one surrounding the other. So let's dissect this inner ear. Let's cut it sagittally. Let's cut it in half, or a sagittal section. And here you can see, we can see the two parts of the inner ear. One part of the inner ear is the outer part, right? The outer part that looks kind of like bone structure or bone color. It looks bony, and because it looks bony, I'm pointing at it right there, it's called the bony labyrinth. Why is it called labyrinth? The word labyrinth means like a maze. Has anyone ever seen that movie, The Fantastic Voyage? The Fantastic Voyage. It's an old movie from 1960s, but it's a wonderful movie for students who are taking 203 to learn about blood vessels, right? Blood vessel circulation, where these people on a little tiny submarine, they become so tiny, microscopic, that they go into the veins and arteries, and they travel throughout the circulatory system, and they get to the inner ear like this. Anyway, imagine you were tiny, like those people in the Fantastic Voyage, right? And you got into the inner ear, right? You came in here, into the inner ear, anywhere here. You would get inside, like those people in the Fantastic Voyage, because it's like a maze. See, all around, you would travel throughout all parts here of this maze. Okay, you would go perhaps here, maybe you'd end up here in the snail-like portion. Anyway, let me get my black line here to point and label the bony labyrinth. So the bony labyrinth is that bony part of the inner ear. Let me move my arrow away for a moment. If I need to use my arrow again, I will. So the bony labyrinth is that part that surrounds the inner ear, right? The part that looks bony-like, right? Let me show you with the figure from before. Let's go back to my figure once again. And right there, you see that it looks like bony colored, bony structure or bony type, all of the inner ear. That's the outer part. So you can see here within the snail-like portion or the rings, it looks bony. That is what we call that outer layer called the bony labyrinth. Now the bony labyrinth is filled with a fluid. The name of the fluid in the bony labyrinth is called, let me underline that word, I'll use a red marker here, is called perilymph. Now you do have perilymph not only in the snail-like portion, but you do have perilymph all around. The perilymph here, I believe, is represented with sort of that orangish color. See the orangish color? So within your bony labyrinth, within this bony part of the inner ear, here you can see bony labyrinth. Inside of it, you have a fluid there called, and here you can see again the bony labyrinth. Inside of it you have perilymph. Once again, here you can see perilymph represented in orange color, like kind of a honey colored or pineapple color. And once again, could you see it here? You don't see it here because you would have to dissect the inner ear. You'd have to dissect any part here within the inner ear. But inside of it, you have this perilymph. Now, the perilymph, right? The perilymph is important for a few things. One thing the perilymph does, as you can see here on this figure, see the perilymph? It flows. It flows like waves. So when sounds come into your ear, it causes these different things to vibrate and finally causes the fluid there that you see called perilymph to flow. See the wavy lines? That represents this perilymph flowing in wave, in a wave-like fashion. It starts to move like ripples on a pond. You ever throw a rock in a pond? You see the ripples? Nobody likes to play with rocks in a pond? Like to skip them? Okay, so good. So that kind of makes little ripples here, just like it does here with this fluid here. So the orange colored fluid that you see here is a representation of the perilymph within your bony labyrinth. Now, what is the other layer? The other layer is the one that's represented in a sort of blue line. So let's look at my figure once again. You can't see here because you'd have to dissect the inner ear. But we can see here in a better view. And you see right there that we have a blue membrane. A blue membrane, which I'm going to point at here. I'll point at one area of that blue membrane. Okay, you see right there a blue, like a dark blue or a blue membrane there. That is called the membranous labyrinth. The membranous labyrinth. That's why it's called membranous, because it's like a membrane. A more delicate, softer membrane. Membranous labyrinth. Let me write this down. And I'll put a marker there as well. Membranous labyrinth. Labyrinth. Again, a labyrinth means like a maze. So you have kind of like a maze here, deep inside your ear. Let me move my arrow away and put a pointer to point at the membranous labyrinth. I want to make my pointer a black color, just like the other pointers here. Okay, so you see the membranous labyrinth. Now the membranous labyrinth is filled with a second fluid. The second fluid is labeled there. So now let me get my red marker and underline the name of the second fluid. So within the membranous labyrinth, by the way, is floating. It's floating, is supported, sustained by the perilymph, right? The perilymph, which is the orange fluid, supports, sustains, and floats the membranous labyrinth. But the membranous labyrinth has a second fluid within it. A second fluid that you see there in a light blue color all around. See here? That light blue colored fluid up here, a light blue colored fluid all around, whether it's here or in the snail, that's called endolymph. Endolymph. So you have these different layers, each filled with a different fluid. The perilymph supporting and sustaining the membranous labyrinth, and the membranous labyrinth containing its own fluid, endolymph. So you have fluid within fluids, fluid within a chamber, within another fluid, and so forth. Okay, can I show you the endolymph? Yes, let me show you here. So right here you can see the membrane that's very thin right there that I'm pointing at. Okay, that would be the membranous labyrinth. Okay, and then you have fluid inside, the fluid which you see right there in a light blue color. It's actually more like clear colored, like water, but here it's represented in blue, would be the endolymph. Okay, the endolymph. Okay, so now what I'm going to do is to help you understand how you have these different layers of the inner ear and fluids. This is a good diagram to understand that. This is just schematic. The inner ear doesn't look like this, but just a schematic representation. Imagining that you uncoiled that part that looks like a snail. So you get a better view. Anyway, here this is also a good figure. So you can see these different things. Okay, so I'm pointing right now at the endolymph. Anyway, to help you understand more clearly, let me get here. Okay, let me show you what I have on my table. I'm going to bring down my camera. Give me 1 second, please, while I set this camera down and to a better view so that you can see my table. Yes, please hold on 1 second. Okay, there we go. Let me turn on my camera now. Okay, so you see some items, some simple items that I have at home. Well, the strawberries is not part of the experiment. That was part of my breakfast. But anyway. Okay, so you see that I have my jar of water. Okay, I put a jar here. The jar represents like the bony labyrinth, right? The bony part here, the bony labyrinth of your inner ear. So you see here, like bony, you know, delicate. It could break like glass. Okay, okay. Actually, it would look more like bony colored. So this is just a jar. If I had a bony colored jar, it would be great, but I don't. But just pretend that this is the bony labyrinth, and inside, the fluid inside this bony labyrinth is your perilymph. Now, secondly, I have a balloon here. See a balloon? A balloon that I will use. See how it's more membranous-like? Membranous? A balloon that I'm going to represent as the membranous labyrinth. The membranous labyrinth, which is filled, see, it's filled with a second fluid. The second fluid within the membranous labyrinth is what? What is this fluid?
Endolymph.
Endolymph. Good. So now, let's put my membranous labyrinth with the endolymph that's represented in here. Let's put it into the jar, just like it is with your inner ear, right? So the membranous labyrinth represented with the balloon, containing its own fluid, which I'm going to call endolymph, right? So now, this gives you perhaps a better picture. Okay? So there we have a representation of the bony labyrinth, the perilymph, the membranous labyrinth. See, I'm poking at it, and inside of it is my endolymph. Okay? Is that clear, guys? Does that help a little? If it doesn't help, you can always look at the figures that you have here in the book. Okay, so how is this all associated? On an exam, they could ask to name the layer, right here, one of the layers of the inner ear. Let me turn off my camera now. One of the layers of the inner ear with a model, like for instance, like this. And if they point here, name this layer of this part of the ear, that will be bony labyrinth. Or they can ask, name the fluid inside. Name the fluid here. They do also have a model like this, a model similar to this, where if they point inside like this, it's more of like a, I think it's more like a bluish greenish color. Anyway, when you see that inside there, that would be a different layer called, right, it's called the membranous labyrinth, and the fluid inside is endolymph. Now there is one other model, perhaps I'll show you later on, that looks kind of like this. This is a section of one part of the inner ear that's been cut like this in half to show you here the cavities, the spaces, right, and the fluids, right? So here we can see the fluids that we mentioned a moment ago. We see here, actually let me get a line to underline. We see perilymph up here and perilymph down here, represented right there with orange. But you do see endolymph, right? Endolymph, which is in the, just like with my camera, with the model I represented. So we can see that as well. Let me underline that word endolymph. Here on the figure, it's represented in a light bluish color. This is one part of your inner ear that looks like a snail. It's called the cochlea. So now let's take a look, since I don't see any questions so far. We'll come back to this model again, this model that you see on figure B of this page. Now, those of you who are following me, you can turn to page 404 in your lab manual. Turn to page 404. I'll give you a moment. Okay? Okay, so on page 404, you can see some of these things that we mentioned, right, of the inner ear. But another thing that you see there for the inner ear is, let me go back to this figure. Okay. Let me move my arrow over to one side. I'm going to use it again. But you see that the inner ear is also sectioned into three different main portions. Three main portions. Let's look at the three main portions of the inner ear. One main portion of the inner ear is this part that you see here called the cochlea. So now we're studying the parts of the inner ear, the portions. If I go back to the first figure here, you can see the three portions as well. and one portion that you see right there is the part that looks like a snail, called the cochlea. So you see that spiral thing? That spiral thing, that's called the cochlea. Now if you look at the cochlea is innervated by a nerve here, a nerve branch of one of the cranial nerves. See that nerve branch I'm pointing at right? Let me fix it a little. Right there. You see a nerve branch, kind of thick, coming to the cochlea? That is the nerve branch known as the cochlear nerve, right? The cochlear nerve, which supplies the cochlea. The cochlear nerve is the nerve that's important for the sense of hearing. So when we say the vestibulocochlear nerve, we have two parts, right? One part which is the cochlear nerve that feeds, that supplies this cochlea for the sense of hearing. Okay. However, if you look at the nerve, right, the nerve vestibulocochlear nerve, it has a second part, the vestibular nerve. Let's look at the vestibular nerve now. The vestibular nerve is this one right here. Thinner, right? Thinner, but just as important, right? The thinner nerve that you see there is going to go towards the vestibule of your inner ear. So that's the second important part here of your inner ear, the vestibule. Okay? The vestibule, by the way, let me shade some of these key words here. Let me get my yellow marker here. Minimize that a little bit smaller. And we saw the cochlea. So I'm highlighting these words. But now the vestibule. So let's look at the vestibule. You see the vestibule is that bumpy area? Kind of looks like a horn, the end of a horn, the end of a... What do they use around this time of the year? They use around this time of the year that thing where they put fruits in it. Looks like a horn. They put fruits to decorate. A cornucopia. Yes. A big trumpet. Whatever. That part is called the vestibule. So you see right there the bumpy area that looks like the end of a horn? It's called the vestibule. The vestibule is that large part there, and it does have different portions. So let's look at the vestibule and the different portions of the vestibule more clearly. You see one portion, again, let me point at the vestibule right here. Now you see my purple pointer is pointing at an area of the vestibule. But with a different diagram, let me show you that the vestibule has, here you can see the vestibule has different portions. One important part of the vestibule is this sac. See that sac or that bump? That sac is called the utricle. Okay, that's that large bump there. Okay? However, close by, next to it, there's another larger bump. This one right here. Okay? That's called the saccule. So we have two important bumps here, or sacs, the utricle and the saccule. One way that students remember this is by the initials US. US, right? Where do we live? Currently, we're all living in the US, right? US, utricle and saccule. So the utricle is this bump closer to the canals, right? Those rings. And the saccule is farther here, closer to the cochlea. Okay? So can we see these bumps? Let me show you. Maybe this is not the clearest picture, but you may see them with some models there, some pictures. And here, perhaps I can point at it. Where I'm pointing here, within that section called the vestibule, I'm pretty much pointing here at this area, right about there, at the bump known as the saccule, while the other bump here, this bumpy area right there, above, right, is called the utricle. So U for utricle, S for saccule. In fact, let me label those two things and move my arrow away for a moment. Let me label it, and let me use a black marker. I'm just going to label it with the initials, US, U, make my initial a little bit larger, U, right about there, and then S, right about here. Okay, do you guys see the bumps that I see there that I labeled? U for utricle, S for saccule. Okay, the U is above the S somewhat. Okay, great. So any question about the parts of the vestibule? So the vestibule has these two parts. Now on the exam, they generally ask you to name these two different parts. Not the vestibule per se, but mainly these two specific bumps, right? The utricle and the saccule more specifically. Okay? So on an exam, you might want to put more specific one of these two things. Okay? They generally don't ask to name the whole structure there, the vestibule, but more specific. Now, that covers now two major parts right here. The two parts of the vestibule, right? And the two parts and the cochlea. So the question would be, name this part and to be specific. Correct. Now, we do have one other important part here of the inner ear. So let's go back to my figure here for the inner ear. Okay, going back to the larger picture here. And you see right there, we talked about the cochlea, we talked about the vestibule, but we have one more part here, and it's those canals that you see there that look like rings. The canals that look like rings, let me highlight the word. They're called the semicircular canals. Now, if you put semicircular ducts, I'll give you credit for it as well. There is a small difference, but don't worry about the difference. We'll just stick to being just more practical. Semicircular canals or ducts will be both acceptable. Anyway, you see semicircular canals there? They are those things that look like onion rings. Okay, see those rings? Actually, there's a set of 3 rings. So these are also parts of the inner ear. So now let's go to the larger figure and see if we can identify those semicircular canals. Okay, we can see here the semicircular canals or semicircular ducts. Again, I'm not going to make a big deal. It really is that the ducts are inside the canals. But anyway, I'll be more practical and accept either answer. So here we have 3 different sets of semicircular ducts or canals. Okay, let's look at the anterior first. See the anterior one? That is the one that's most anterior. How do I know that's anterior? It's the one that is more anterior, meaning that's the one that's closer to the cochlea. The cochlea is anterior. If I go back to my figure from before, look at the orientation here. See, this is the ear, and you see the cochlea. The cochlea is actually more anterior to the anterior, more closer to the anterior part of your face and head, right? So meaning that this one right here, this one would have to be, the one I'm pointing at right there, would have to be the anterior semicircular canal. Sometimes it's also called the superior. See how it's most superior? So you can name it either way, superior or anterior. So here I'm going to put in parentheses, superior or anterior. I'll put in parentheses just underneath the word anterior. I'll abbreviate superior, by the way. I'll abbreviate the word superior. Okay? Okay, so that's the first one that you see right there. Then we have one that is most posterior and that comes down most inferiorly. That one is called posterior, or also known as inferior. If it's easier for you to remember as inferior, then you could put that as well. I'll abbreviate the word inferior. Okay, let me fix that. Bring it closer to the word posterior. So the posterior or inferior, that's the one that's most posterior or most inferior. If you look below, let me get rid of some of these arrows. We no longer need these arrows. Okay, but you see right here, part of the posterior semicircular canal. Okay, part of it comes most inferiorly, so it goes all around. It's kind of big. And there, can I see with a different figure? Yes, going back to the first figure, posterior would have to be this one. See that one? It's most posterior, but also see how it curves and comes way down here. See how it curves? So that's why it's sometimes referred to as also being inferior. So whichever way is easier for you to remember. Now, Lastly, we have this one here, the one that's most lateral. Okay, that lateral is only known as lateral semicircular canal. The lateral, as you can see there, has more of a horizontal orientation. See how it's a ring horizontally? It's also more closer to your ossicles, right? Closer to the ossicles, to the middle ear. So going back to my other figure, this one would have to be the lateral one. Okay? So is it important to review the names of these three semicircular canals? Sometimes, not often, but once in a while they will ask to be specific with one of these. So they could point at one of them specifically and ask you to, which one is it to be more specific? Okay? Anyway, most of the time they just usually just point at one of them and ask, what is this thing, right? And it's just simply semicircular duct or semicircular canal. Okay, so there we have the three semicircular canals. Now, one last thing important here for the semicircular canals is you see bumps here. See these bumps? See that bump right there? Those bumps, the bumps that you have where these canals begin, right? See those bumps? Let me see if I can show you with a different figure. See these bumps right here? This one. This one. They look kind of like knobs. See right there, like knobs? Those are actually found here at the beginning or at the bases of your canals, of these semicircular canals. Those are called specifically the ampulla. Is it labeled here? Yes, it is. You can see right there the word ampulla. Okay, so you have there these bumps there for the semicircular canals. They're like knobs. They're called the ampulla. And if I go back to my original figure here, you can see very clearly there's some of the ampulla as well. Right there is one where I'm pointing at. Here's another one and another one. The ampulla, I'll put a little letter A next to it. Let me move my arrow away and put a small a close to it. Let's put it on the bigger one here. Okay. So there, I'm going to put here letter A right over the ampulla here that we have, one of the ampulla. Okay, you see capital letter A. So now you can see that some way that students remember these three bumps, right? The utricle saccule of the vestibule and then the ampulla here. They're remembered as USA. However, I like the word AUS there because AUS, like Austria, Australia, or whatever, the first three initials of these different countries in the world. Austria, Australia. Whatever helps you is fine. Now, if you look carefully, these three parts here, the utricle, the saccule, and the ampulla, the AUS or USA, or however you want to learn them, okay, see these three parts? These are innervated by this nerve. Let me show you the nerve. And you see that nerve right there? That nerve that's supplying these areas of the inner ear, right, which is the US and A, utricle, saccule, and ampulla, is the vestibular nerve. The vestibular nerve. So now we can see the vestibular nerve is the other branch of this eighth cranial nerve, the vestibular nerve. Guys, hold on a minute. We'll take a break in another couple of minutes. The vestibular nerve. So now we can see that the vestibulocochlear nerve has two branches. The cochlear nerve for the cochlea for hearing. Therefore, the vestibular nerve supplies the vestibule and the ampulla, and it has a different role. What role does the vestibular nerve have? Anybody know? What role does it have? Balance. Very good. Equilibrium or balance. So now, when you talk about this cranial nerve, right, the eighth cranial nerve, by the way, you should review the eighth cranial nerve, right? The eighth cranial nerve, well, is a sensory nerve. It's almost purely, we'll say that it's purely a sensory nerve for the sense of not only hearing, but the sense of balance. You see why I like the word vestibulocochlear, because it gives you the two important functions. Whereas people who call it auditory nerve, when you think of auditory nerve, you just think of hearing. But that's not a full picture. The fuller picture is with the full word, vestibulocochlear nerve. And now you know that the inner ear is involved with hearing and balance through these two branches of this nerve. Okay. So far, any questions? Any questions? Now let me show you some pictures though. Here's the tympanic membrane. You see a healthy tympanic membrane on the left side. When you look into someone's ear, you look into their external auditory canal, you see a healthy tympanic membrane should look like this, like a lightish pink color. You see a few things there. You can see part of the bump there, that's part of the handle there, the handle of the malleus bone, right? The malleus that we saw earlier. And that's on the other side. So we're looking at the external surface here, but you can see a few bumps there of the tympanic membrane because of the bones, the ossicles on the other side of the membrane, right? But here you can see some examples of damaged eardrums, right? Damaged tympanic membranes. One from an infection. You can see that it's very swollen and red. Redness, dark redness, bright redness usually means inflammation and infection. Okay, and here's another example of someone who damaged eardrum. Maybe they stuck something in there, in their ear. Maybe they had a loud bang, right? That's also possible. A loud bang by your ears, like a bomb, right? Soldiers who come back from wars where a grenade blew by their ear can damage their eardrum like this. Okay, there are techniques to help repair, but anyway, you can see a damaged eardrum right here, right? And other complications to the eardrums as well. But one thing also that is common, probably the more common cause of damaged eardrum is people putting things into their ear, like Q-tips, and you go too far, or something else that's pointy, and you stick it into your ear to scratch, and by accident you went too far, and you have this excruciating pain, and also you'll have, your hearing will be affected as well. So anyway, you want to be careful not put things into your ear. Okay. Anyway, if you do have an itch, again, like I recommended, just use a little clean rag, right? And just gently, as far as your pinky can reach. And your pinky doesn't reach that far deep, only on the most outer surface of your ear canal. Anyway, questions about the eardrum? Now the device that's used for looking into the ear is this device that you see here. It's a medical instrument called the otoscope. The ophthalmoscope is used for looking into the retina of the eye, but the otoscope, auto meaning ear. So we use an otoscope, healthcare professionals use an otoscope to look into a person's ear and see if there is some problem in the ear, right? They can see as far as to the eardrum. So when they look into the ear, they will see as far as what you see right here with the eardrum in the first picture. Okay? And it looks nice and clean and clear and healthy and so forth. Okay? So that's the otoscope. Remember, diagnostic tools and instruments you want to review as well. It's possible there could be a couple of questions with one of these diagnostic tools or methods used for the senses, right? For the eye, we had the astigmatism chart, we had the instruments used, we had some other charts, and here for the ear we have an otoscope. Now, for checking your hearing, we also have another instrument. Let's see if I have a figure of it. If I don't have a figure, I'll show you. I don't see the figure here, so let me show you with my camera. Okay, turning on my camera. Okay, and you see right here. Okay, looks like a fork, because it's called a tuning fork, for tuning, like when they're tuning musical instruments, a tuning fork. Okay, I'm gonna do something with it, and you tell me what you hear. Anybody hear anything? Let me try again. If you heard something, you have excellent hearing like Superman. But let's try it again. Let me try a little bit more. Did anyone hear anything?
Yes.
Could you describe? Let me do it one more time, a little bit louder, because some of you may have hard of hearing. Hold on. Try that again. Okay, what did you hear? My dog doesn't like that sound, by the way, because they have very fine hearing. They can hear that from yards away. Now, for those of you who have difficulty hearing, maybe you're losing your hearing already. I'll do it louder now. Okay, that probably you should have all heard that now. If you can't hear that, you need to go get your ears checked. It sounds like a screeching sound, sounds like a humming, sounds like a ringing. Yes, that ringing, that sound that you heard, like a humming, like a buzzing, that is produced by this tuning fork. That tuning fork is used, the tuning fork you see here, is used for checking a person's hearing ability, right? How well they can hear things, okay? My hearing is pretty good. My eyesight is not the best, but my hearing is excellent, probably as good as my dog's hearing. So my dog, as soon as she heard that, she came into my room from 2 rooms away. And they don't like that sound. But anyway, any questions about that thing? It's called a tuning fork. Let me write that down. And you'll see it, by the way, actually you'll see it on your review list. So when you go to your review list, at the very end of your review list, on page 2, you'll see there some diagnostic tools. You have there the tuning forks. There are different types and sizes of tuning forks, but in general, they look something like what I showed you. Okay, any questions? Now, with models of the ear, by the way, we're spending quite a bit of while with the ear because there is a lot of material here with the ear. Lots of things can be asked with the ear. With the other senses, not much. We'll get to the other senses after the break. But with the inner ear, they also have a model like this that looks like the figure B on this page, figure B. So you can use figure B here, and you see there are different cavities in the cochlea. So look at the cochlea. We dissect the cochlea, and you have their different spaces or cavities, right? The middle one is called the scala media. Let me highlight these words. Let's get a highlighter. Okay, scala media. Okay, the scala media, that's the one that's filled with endolymph. Okay, the other 2 scala are the one above a slanted line. The slanted line, by the way, is called the vestibular membrane. See the vestibular membrane? So the cavity above it is called scala vestibuli. The word scala means a cavity. Scala means cavity. So you can also call it a cavity, okay? The vestibular cavity, or scala vestibuli. The lower one, the one below it, is called scala tympani. I try to highlight it as best as possible. Anyway, so you have there two cavities that surround the scala media. The scala media is the middle one, also called cochlear duct, filled with endolymph. But the two other cavities, scala vestibuli, is above a slanted line called vestibular membrane, while the other cavity is the one that is below the basilar membrane. You see a basilar membrane, which is more flat, horizontal. So I'm going to highlight that word as well, the basilar membrane. So there, when you look at that model, you'll find these different cavities and the different fluids within these cavities. Now, one other important thing here, you see that small area with a box in the center of figure B? That's area. Within that small area, we have an important unit of structures. We call that unit that's kind of spiral shaped because of the cochlea. It's spiral shaped. We call it the spiral organ of Corti. Let me take a different figure here. So there you can see with the figure, the spiral organ. Let's highlight this word. This is figure 15, a different figure, 15.29. If the previous figure was 15, whoops, I lost the figure now. Okay, but 1526. So there you see the spiral organ of Corti. or simply the organ of Corti. Okay, organ of Corti. Corti, named after this Italian scientist, Professore Corti. Okay, so named after him, we have this area. Now, if you look at the area, it doesn't look too large, very tiny within the cochlear duct. So within the scala media or cochlear duct, you have this spiral organ or the organ of Corti. But let's magnify it because there are a few details there with the big model. With the big model that I'll show you later on, you'll see that there is details in the spiral organ. So let's make that a little bit larger with figure 1529. Where's that figure that I saw a moment ago? Right here, 1529. So let's take a look at this spiral organ or the organ of Corti and magnify it. So when you magnify it, you see right there, one thing that you see is that we find these little red colored cells on the figure here. They're called the hair cells. Hair cells. There's no need, by the way, to specify the inner or the outer hair cells. Just simply the hair cells. So I'll highlight the word hair cells. And you have different varieties of hair cells. But you know the hair cells are the ones that have the cilia. You see the cilia? The cilia, which are like little hairs. The cilia of these hair cells. So I highlighted the few important words there. The cilia and the hair cells, right? Above the hair cells, you have this membrane. The membrane, which is called tectorial membrane. See the tectorial membrane, that white thing? The tectorial membrane. And then below it, remember we had the basilar membrane. Below the hair cells. You also have supporting cells. You can see some supporting cells. They look more columnar shaped, the supporting cells. They support the hair cells. And lastly, we have here fibers, the fibers of the cochlear nerve. So those little yellow fibers that you see there, with the model you'll see little yellow fibers. Those are fibers of the cochlear nerve. By the way, review very quickly the microscope slide for the spiral organ of Corti. Microscope slide that you see here with figure B. Okay, looks pretty simple. Okay, whereas the retina, remember the retina of the eye is more complex, has many layers of cells. But here you can see that it's very simple, just like the figure that you have here. So there will be some of the important things that are highlighted here for this diagram. Okay, the hair cells, the supporting cells, the tectorial membrane, the basilar membrane, the cilia, and then the fibers of the cochlear nerve. These fibers of the cochlear nerve are the ones that will innervate these hair cells so that when the hair cells move, when the hairs, the cilia move, they stimulate the hair cells and the hair cells generate nerve impulses which go through the cochlear nerve and to your brain to interpret sound, noises, and all kind of things that you will perceive with your hearing. Okay? We will discuss what you see right here with hearing in lecture class. But you're welcome to use this just to understand some of the anatomy if you like. But we'll use this diagram more specifically in lecture class. Okay, the other part important here of your inner ear, what you remember was the sense of balance. So here we have the two nerves, the nerve for hearing and the nerve for balance. Okay? Questions? Any questions, guys? Any questions?